In this video, we will learn how to use Gauss-Jordan elimination method to solve system of linear equation. Previous video, we already see how to solve the linear equation using adjoint method or using inverse matrix. In this video, we will see how we're going to use Gauss-Jordan elimination method to solve the linear equation. And if you still remember from the previous video, I said that if you want to find the inverse of matrix A, we didn't use ERO. Because if we use ERO to find the inverse and then multiply with B, that is a redundant way because we can use ERO to actually solve the linear equation directly, okay, without finding the inverse. To solve the linear equation using Gauss-Jordan elimination method, the first step is the same, which is we're going to write the matrix equation AX plus B, and then we're going to form the augmented matrix AB, and then we're going to perform ERO to reduce the augmented matrix to the form of IX. And actually, it's the same with finding inverse using ERO. So in general, from the matrix equation AX equals to B, we change to augmented matrix and then we perform ERO until we reduce the augmented matrix to the form of IX. And the matrix at the right hand side here is the solution for the linear equation. So let's take a look at an example here. Alright, so for example, solve the following system of linear equation using Gauss-Jordan elimination method. So we have three equations here. X minus 3y plus z equals to negative 12. X plus y plus z equals to 0. 2x minus y plus z equals to negative 8. Write the matrix equation first. AX equals to B. For matrix A, this is 1, negative 3, 1, and then 1, 1, 1, 2, negative 1, 1. This is for matrix A, and X is X, Y, Z, and equals to matrix B, which is the constant at the right hand side, which is negative 12, 0, negative 8. Alright, so you must write first the matrix equation. Alright, so from the matrix equation, we're going to form the augmented matrix. Okay, augmented matrix A, B. Alright, so that's mean we just copy matrix A at the left hand side. And then we have a vertical separator here. And then at the right hand side, we have matrix B, negative 12, 0, negative 8. So it's the same with doing ERO. The method is the same. Alright, so first we're going to make this element 0. So to do that, that's mean we need a new second row. Alright, so the equation is, alright, so since the targeted element is at the first column, that's mean our subtrahend will be at the first row. So we're going to use this element, which is 1, and our targeted element is at the second row, and the element is 1. So we cross multiply this. First we have R1, this become R2, and then minus. So the equation is R2 minus R1. Alright, so you can use calculator to calculate this equation, or we can do manually. So for first and third column, we can just copy them back to the augmented matrix because nothing will happen to the first and third. So they are only change for second row. Alright, so it's just second row minus first row. First is 1 minus 1 is 0, and then 1 minus negative 3, which is 4. 1 minus 1, 0. 0 minus negative 12 is 12. Alright, so we're done with the first step. Alright, second step is to make this element become 0. So that's mean we need a new third row. Okay, so the equation for the new third row, So our subtrahend will be at the first row because the element is at the first column, and the element which is at the first row and the first column is 1, and then the targeted element is at the third row and the element is 2. So we cross multiply, it's become 2r1, this is r3, and then minus. So the equation is r3 minus 2r1. So you can use calculator to calculate this. Alright, so that's mean the first and second column we have no change, so we just copy them back. Alright, so we can calculate this. So the row is 2, negative 1, 1, negative 8, and then first row multiplied by 2, so 2, negative 6, 2, negative 24, and then minus, so 0. So this is 0, this is 5, this is negative 1, negative 8, minus negative 24, 16. So this is 0, 5, negative 1, 16. Alright, so finish with the second step. Okay, third step is to make this element become 0. So that's mean we're going to have a new third row. Alright, so since our targeted element is at the second column, so we're going to use second row as a subtrahend, and the element which is at the second column and second row is 4, and then our targeted element is at the third row and the element is 5. So cross product, this is 5 r2, this is 4r3, and then minus. So the equation is 4r3 minus 5r2. Alright, so that's mean first and second column will have no change, so we just copy them back. Alright, so I'm going to use calculator for this. So first one 0, also 0, negative 4, this is 4. Alright, so we managed to reduce this augmented matrix to become 0 at these three elements. Alright, so if we look at the third and second column, this is actually already done because this becomes 0, 4, 0, and this is 0, 0, negative 4. So we can change this to 0, 1, 0 and 0, 0, 1. Okay, the way is we can, for the second row, what we can do, we can multiply with 1 over 4. And the third row, we can multiply with 1 over negative 4. Alright, so if we do that, so this is 1, negative 3, 1 for the first row, nothing change. And for the second row, it's become 0, 1, 0. Okay, 12 over 4 is 3. And this one becomes 0, 0, 1. And then 4 divided by negative 4 is negative 1. Alright, so that's mean we already left with these two elements. So this element must become 0. So to that becomes 0, we can, that's mean we need a new first row. Alright, so the element is at the second column, so we use second row as a subtrahend. The element is 1, and then the targeted element is at the first row, negative 3. So cross multiply, negative 3 r2, and then this is r1 minus minus, so r1 plus 3 r2. So we have r1 plus 3 r2. So if we do that, so second and third row is no changes, so we just copy them back. Alright, so for the first row, it's become 1, 0, 1, negative 3. Alright, so the last step is to make this element become 0, and that is very simple because we just take, okay, the new first row is first row minus third row. So when we do that, it's become So second row, nothing change. Third row, also nothing change. Only the first row. Right, so 1 minus 0 is 1. 0 minus 0, 0. 1 minus 1, 0. Negative 3 minus negative 1, negative 2. Alright, so we finish with the Gauss-Jordan. So if we look here, this is identity. That means this is the solution that we want to find. So that is the matrix X. So we know that X is equals to negative 2, 3, negative 1. So that's mean X equals to negative 2, Y equals to 3, and Z equals to negative 1. So that is how we use Gauss-Jordan.